The Freightliner eCascadia is capable of charge rates up to 270 kilowatts and can carry up to 438 kilowatt hours of usable energy. However, charge times vary considerably based on vehicle configuration, charging equipment type, and the amount of energy the facility can deliver to the charger. Charging at a lower rate, or trickle charging, can also help fleet managers realize lower overall energy costs. The eCascadia utilizes two types of batteries: low-voltage lead-acid batteries, which power the vehicle's HVAC, lights, controls, and in-cab features, and high-voltage HV lithium-ion batteries that provide energy to the truck's electric drive motors. When the vehicle's drive system is switched on, the HV battery provides power to replenish the LV batteries, much like the alternator on a diesel truck. The eCascadia operates on a 400-volt nominal electrical system compatible with CCS1 DC fast charging equipment, the most common standard available in North America. For the eCascadia, two Detroit battery options offer choices for usable capacity and average 0 to full charge times. Using a charger that can deliver between 70 and 180 kilowatts, the 291 kilowatt-hours battery available on the 4x2 eCascadia will charge in 2 to 4 hours. The 438 kilowatt-hours battery will charge in 3 to 6 hours, or about 2 hours when using dual-port charging. The best fit use cases for the eCascadia are routes of roughly 150 miles per day that allow for overnight charging at the lowest possible charge rate during off-peak hours. Routes of this length typically enable drivers to keep the batteries between 15% and 85% state of charge, SOC, which helps to optimize overall battery lifespan. For duty cycles that require a quicker recharge to add a second shift or extend routes beyond the central charging hub, the best fit use cases will rely on a 0 to 80% recharge, due to the gradual reduction in charging speed that occurs as the batteries fill from 80% to 100% SOC. The standard eCascadia charge port supports charging up to 180 kilowatts. If daily fast charging is critical to a particular use case, the 438 kilowatt-hours battery pack option can also be paired with a second charge port on the truck. With both ports charging simultaneously, one receptacle can receive 180 kilowatts, while the second accepts an additional 90 kilowatts, adding up to a total charge rate of up to 270 kilowatts and reducing the recharge time by 1/3. Recharge times can vary widely depending on the charging equipment available, power available to run that charging equipment, and can be adjusted depending on duty cycle to maximize cost savings potential. The vehicle must be stationary, the park brake engaged, and the e-stop button released for the vehicle to charge. If vehicle movement is detected or the e-stop button is pressed during active charging, charging will terminate. If the park brake is released when a charge coupler is plugged into the vehicle inlet, charging stops. A warning window appears on the driver display, and a continuous chime will sound. Engage the park brake to dismiss the warnings and start a new charging session. Before charging is initialized, leave the key in the on position. Once charging has started, the driver can turn the key to the off position and remove it from the ignition. Open the charge port access cover. Remove the charge port inlet plugs and verify the inlet is unlocked. Both the inlet status lamp and the inlet lock lamp should be illuminated white if the inlet is unlocked. A label outlining the meaning and sequence of the inlet status and charging status lamps is shown affixed to the inside of the charge port access cover. Follow directions on the charge dispenser screen about payment or identity verification needed to start the charging process. Remove the coupler from the charge dispenser. If necessary, press the coupler's top latch button. Plug the coupler into the charge port inlet. Listen for a loud click that indicates the coupler is fully engaged. When the coupler engages, the stop charging button lamp illuminates white, and the inlet status lamp and inlet lock lamps go out. As a connection is established between the charger and the vehicle, two lamps pulse orange, the charging status lamp and the battery charging lamp. When the connection is made and the charging of the high voltage batteries begins, these same two lamps pulse green. When the vehicle is done charging, the charging status lamp and the battery charging lamp illuminate a steady green. The charging station should also indicate on the screen if a charging connection has successfully started. For charging stations that do not have a payment interface or HMI screen, such as depot charging dispensers, watch for LED lights that will indicate any possible issues with the charging connection or confirm that charging has begun. A vehicle is done charging when the high-voltage batteries have either charged to 100% or reached the target state of charge, SOC. If the batteries are fully charged, the charging session will automatically stop. Press the coupler's top latch button and remove the coupler from the inlet. If the batteries are still charging, indicated by the charger status lamp pulsing green, stop the charging process and automatically unlock the inlet by either pressing the Stop Charging button next to the inlet or pressing the Stop Charging option on the charge dispenser. Put in the charging inlet plugs or latch the doors and close the charge port cover. If equipped with dual charging ports, the vehicle may still be charged with a single charging coupler using either inlet. Single port charging can only charge up to 400 amps or up to 180 kilowatts. On a vehicle with dual port charging, the power supplied by the charger connected to inlet 1 or the forward inlet is double the amount of power supplied by the charger connected to inlet 2 or the rearward inlet. When both inlets are used to charge the vehicle, inlet 1 charges battery 1 and battery 2. Inlet 2 charges only battery 3, and 2 plug telltales appear on the driver display, one for each coupler. If a vehicle is charging in single port mode and a second coupler is inserted, the charging current demand on the first port are reduced as the vehicle controller recalibrates current demand and carries out safety checks on the second coupler inlet connection. When the second coupler is ready, current demand increases on both inlets to charge the vehicle. The process to terminate charging when both ports are engaged at once is the same as charging with a single port, giving the driver multiple options to stop the charge and release the couplers. The eCascadia can also be programmed to charge at a specific time instead of needing to initialize charging the moment the charger is plugged in. It's important to note that keeping a high-voltage lithium battery fully charged or deeply discharged contributes to a shorter overall battery lifespan. In general, a battery lasts longest when kept between a 15% and 85% state of charge, or SOC. On the infotainment screen, select Settings or the gear icon. Select Charge Battery. The Charge Battery menu contains 2 options, Departure Time and Charging Limit. Departure time causes the vehicle to draw power at a rate that results in the batteries reaching their target SOC by the departure time and activates the preconditioning feature. When no departure time is set, the vehicle draws the maximum power available until the target state of charge is reached. In this scenario, the time displayed represents when the target SOC will be reached. Charging Limit sets a target SOC for the high-voltage batteries. Choose Departure Time and enter the planned departure time. The scheduled departure time can be set to repeat over multiple days. A desired cabin temperature for the departure time can also be specified. Select the back arrow to return to the charge battery screen. Note that the lowest accepted charge limit is 50%. Select Charging Limit and drag the circle on the percentage bar to set the desired charging limit. This changes the maximum charging limit on the battery icon. Preconditioning is a feature that maximizes energy efficiency and vehicle range while also ensuring driver comfort in hot or cold weather conditions. While the vehicle is still connected to a charger, preconditioning initiates the cooling circuit for the HV battery as well as the cab HVAC system to ensure that by the time a driver's shift begins, the e-powertrain and cab are already at an optimal operating temperature to perform without consuming extra energy. Preconditioning status is displayed on the Dash B panel screen of the truck, as well as the Detroit Connect portal, allowing either the driver or remote fleet manager to set departure time and preferred cab temperature. The vehicle does not have to be connected to a charger to set up charging limits or schedule departure times, but while scheduling a departure time sets up preconditioning, the feature will only activate if the vehicle is plugged into a charger. If cab climate control is activated when scheduling a departure time, preconditioning activates the HVAC system to bring the cab to the desired temperature by the scheduled departure time. If the scheduled departure time passes and the vehicle remains connected to the charger, preconditioning keeps the batteries, e-axles, and cab at the desired temperature for a set amount of time. Preconditioning deactivates if the charging cable is unplugged, the key switch is activated, or an HVAC setting is manually changed. If the vehicle has reached its target SOC or achieved a 100% SOC, the charge battery screen displays a "not charging" message. The current kilowatt amount being delivered shows as 0, and the current high voltage battery SOC displays in white. On the driver display screen, the blue plug telltale is illuminated. If a fault has interrupted the charging process, the charge battery screen displays an "error/charging interrupted" message, and the current high voltage battery SOC displays in amber. If the initialization steps are followed, but the vehicle does not begin charging, 1. Verify the e-stop button is released, the park brake is set, and that the vehicle is stationary. 2. Verify a target SOC has been set and has not been reached. 3. Unplug the coupler from the vehicle inlet and plug it in again.